first order of business, I want to kind of address what cellular automation is, if people aren't familiar with it already. How about it, crowd? Have you encountered cellular automation? Have you a good idea of what it is? And also, what are these glowy things?
Game of life, wire world.
All right, so
the most common ones.
So I guess we have some really widely varying experience here. So I might want to go back a little earlier than I had planned and mention what cellular automation is. We just saw TIS 3D, and that's actually a form of cellular automation. But the simplest kind we had up on the back of the screen while all of that was going on, which is a simple black and white cell thing. Well, there you go. I think we're getting links out to little cellular automations.
No, that's just a log calculation.
Oh, okay.
A cellular automation, though.
Yeah, go back and look at them on Wikipedia. They have great animations on it. The reason that we're talking the reason that we're talking about this is because Notch has always had this fascination with cellular automation. It's built into a lot of the fabric of this game. The idea that there's a rule called Rule 30, and that we actually proved that cellular automation can do anything that a modern computer can. I think somebody's hot micing.
Mesh, I think.
And because of that, we got the ability for Redstone to do literally everything a normal computer can. It's what we call Turing complete. But we've gone, Rule 110 is another one, and then that kind of dovetails in with things like the DCPU and the open computers. We want to make really complicated emergent behaviors in our blocks. So I'm going to touch on a lot of those things, but if you're not familiar with it, go back, because Conway's Game of Life is really fun to play with. So one of the hallmarks about cellular automation is that kind of emergent behavior. You take a lot of little dumb cells that only know how to talk to their neighbors or look at their immediate neighbors. Conway's Game of Life, just a cell stays alive if their immediate neighbors are alive. If the right amount, they can get overcrowded and they can get lonely and die. So when we're looking at, let's say, the behavior of water, we actually also have a lot of kind of cellular behaviors. A given flowing water looks around it, and if it's the tallest flowing water, it'll actually start to lower until it's gone. Problem is, because there are so many individual cells looking at their neighbors, sometimes you flood your quarry and then you drain it, and it takes an awfully long time for all of that water to flow away, because every single cell on the top is trying to figure out what height it should be based on its neighbors. Now, a couple of people like me look at the state of Minecraft modding and say, man, wouldn't it be cool if we could move away from these like little all-in-one boxes that are extremely smart and have GUIs into a much more yes. This is a variation on Rule 30. Can we get the other slide up? I don't know. Because the other slide is the standard Rule 30. This is a variation of it. But I was thinking we could get kind of exploit people's tendency to go towards first order optimization. Like one furnace is good for smelting my metal, but what if I made 10 furnaces? Then I could smelt it 10 times faster. Well, imagine if you could encourage people to build giant, steam factories with pipes running everywhere, and each block does something very simple, but only talks to its neighbors. Yeah. So I was kind of looking towards that potential future. And I decided to make a heat simulation. And I wanted, let's say your magma crucible. I wanted it to be instead a radiator, and the radiator would heat up nearby blocks and melt them into lava. Emergent behavior like that. You have a radiator, the radiator does a lot of things. Something really simple would just heat up nearby blocks. And the emergent behavior is you can make a magma crucible out of it. Well, so I started thinking maybe you could do a lot of things out of this. I placed a firebox, a furnace that burned coal against a cave wall, and proceeded to watch my simulation turn the blocks around the furnace into what I called conductive imposters. And then I had the heat diffuse from there into the surrounding stone, and the heat diffused from there into the surrounding stone. And Minecraft's infinite, right? We caused the eventual heat death of the universe.
Except the opposite way.
So, I have to say, that really changed how I thought about building machines. I am absolutely for the... great. We have Rule 30 up on screen. Sorry, turning around. We can't simulate everything in a cellular fashion. And in fact, if you try, you wind up with some very strange behaviors. So let me try and dissect what's going on here in the image. The top row of this image, let's say it's a horizontal line of redstone blocks. And then, given the rules of the simulation, that will evolve that redstone over time. So maybe some is lit and some is not, and it doesn't behave quite like redstone because it's Rule 30 and not redstone. But the vertical axis, as you go down, you're evolving over time. And so Rule 30, if you apply it in a discrete fashion, each row is considered by the next row. In generating its the next step of the simulation, you get this really cool-looking mathematical pattern. The other slide, which we saw earlier, I don't know if we can get that back up there. Minecraft does not hold a full discrete state, like a last state and then the next state. All of these blocks are live right now, and when let's say a block over here changes, that block changes, and it could snowball into other blocks, but it's that tick, something over here might change, and look at the first block and see the new state and not the old. This lack of discrete state means that we're not actually dealing with a cellular automation. What this is an asynchronous variation. Same rule, all the blocks are looking at their neighbors and making determinations on what their next state should be. The only difference in this image from the previous image is the order the blocks are updated in. And in this case, it's updated in random order. So just taking away that full, let's say, representation of the world last tick and having that separate from the representation of the world next tick, it causes this huge cascade of messy, different behaviors. It also creates your southeast bugs because you don't have an atomic state for the world. So when we start to look at how we design machines, obviously the fact that Minecraft is not a cellular automation at this point makes a huge difference. The other thing is the scope. I mean, this is a really, really small world here. It's, I don't know, hundreds of blocks across, and we have a three-dimensional world with 30,000 kilometers. We can't simulate all of that every tick. It's just not going to happen. Even if we put it on a GPU, it's not going to happen. So it's not just that we don't have a cellular automation here. It's that we can never have a cellular automation in Minecraft. So we definitely need to change the way we think about building those kinds of large-scale factories. So I kind of want to talk about a couple of ways we could potentially escape that without, let's say, limiting our scope, which I think the TIS 3D does a really great job of doing cellular automation by limiting the scope. You can only place so many blocks against a controller. That's what I mean. One way is to unhook from the block grid. And we're doing this already in huge ways, like the fact that we have a monitor. I think we're going to look at my heat death now. Yeah, there it is.
Beautiful, man.
We even got a laser in there, man. So that's previous version of Engination.
Yeah, this is the heat simulation he was talking about. The silver thing you can barely see in the background is a firebox. It generates heat and propagates them to nearby blocks, and the glowing red blocks are what he previously described as conductive imposters. They're a tile entity that stores heat information.
Gotta love those lasers for pointing the way.
I'll let you continue, Vakra.
Yeah, the laser is primarily for light in this image, but I would love to bring those back. They were pretty cool. Actually, yes. I would love to make Engination hot again. I think that would be fun. But we'll get there. But what I want to direct you to is the fact that we've connected all of these monitor blocks into a large monitor. And I think that's one of the ways that we can start to address the limitations in cellular automations, because if we work in these large solids all at once, then suddenly there are far less things to automate. And honestly, something like a big screen or a giant, just to throw things out there, a large coke oven or an industrial grinder, these are things that we've already started to see. The problem is, at this point, one of the challenges that we face, because multi-block, like rectangular solids, sorry, I want to scroll here through my notes. There are a lot of things that we could do with rectangular solids that we're actually not doing yet. We could actually reduce the number of faces on this. There are some challenges to that. Right now, for instance, we've got a texture atlas, and that prevents us from using UVs to repeat textures. We've got Minecraft lighting engine, the way Minecraft does occlusion culling. I don't want to get too technical, but have you ever heard of the bug where, let's say you have a bunch of maps in item frames hung up on your wall, and if you look at it from the corner of your eye, it'll disappear? That kind of bug would rear its head again if we tried to sort of inject true rectangular solids into Minecraft. But I think, yeah, it does happen with normal blocks. Minecraft's occlusion culling needs some work. But imagine what we could do. We could create prefab arches, and maybe instead of flamingos, we could have pink alpacas or something, like big ones. We could have prefab building pieces. I've been playing a lot of Arc lately with the snappable pieces, and I think that's really convenient and fast. Now, Arc could learn a lot from Minecraft too. But, we have some possibilities. Other possibilities we have are reducing the amount of logic. Let's say we have a pipe that moves items from one place to another. A rectangular solid could be an intermediate step between, let's say, an Ender.io style pure network and say charset style sort of dumb pipe. Downsides, of course, as implemented, a lot of the blocks in a rectangular solid don't actually do anything. And I've always kind of hated that. Coke oven, most of the coke oven blocks are there really to make it look big and impressive and to increase the cost, which I have some arguments about for balancing. I don't think that that's an appropriate way to balance. Sorry if I called you out your mod, because Railcraft and IC2 and RegTech, they've got a lot to recommend them. And I think we could redo that If we could get some sort of placement, like all at once placement, I think that could address a lot of my concerns there. So, all right, let's say we're never going to get rectangular solids. There are a lot of hurdles there. What else could we do? We could try to, through some of the advanced tile entities that we're starting to get, we're batching tile entity data and sending it to the client together. So for instance, we've got these just gorgeous chisels and bits blocks, and those are all tile entities. And they're not costing us very much, which is really surprising to me. Oh my goodness, we have a rectangular solid multi-block. But yeah, I think what I'd like to see in the future is the ability to place this all at once with a big placement marker, so that we could just know where we're putting it. But I definitely think that machines like this are going to be part of our future. No sense in fighting it. So if we are really dedicated to individual cellular single blocks, you know, the TIS 3D is a great model for that, limiting the scope. Hold on, let me grab a block for you. So there are a couple of different ways to limit your scope. You could potentially just limit it in one direction. I like limiting things in the Y direction, and downward consolidation is actually very natural here. So, for instance, some of the first machines I threw into this mod, into this version of the mod, were just batteries and generators. Because, oh, come on. There's going to be a gear here. We're working on it. But yeah, because I can't, you can only fit 256 of these. There's a limited scope for simulation, and so that helps save the server some potential headaches. The benefits of this, it emphasizes, rather than material cost, it emphasizes kind of the creativity and skill of the player, which is why I tend to leap for this solution in particular. But again, we've got some hurdles because Minecraft is not cellular automation, so I might want to talk at the end a little bit about the possibility that we could move on to a kind of message passing concept. The other problem with cellular multi-blocks, such as the battery stack, currently the built-ins don't work very well. The hopper and redstone, they're plagued by lighting updates, terrible performance for tile entities. They don't use the component systems. In a lot of ways, in this area, we're actually, Forge is way ahead of vanilla. And as we can tell behind me, the more popular we make our true multi-blocks, the closer we get to the eventual heat death of the universe. We still have some space to explore in the kind of smart multi-block vein. And what I want to... one example I'd love to throw out there is Ender.io. Particularly because Ender.io achieves some of the best performance. Like Ender.io and Chisels and Bits constantly amaze me by how fast they do. I'm doing great with grammar. How quickly they do what they do. And they do that by doing proactive network scanning. And then from there, a lot of the conduits that you walk past every day are just bookkeeping blocks. They get rescanned every so often, but what Ender.io cares about is network topology. It's achieving speed by getting out of Minecraft code as quickly as it possibly can. And that's definitely an option for us as developers. The downsides of that method, I think, are sometimes you wind up having to store a lot of that data that isn't part of Minecraft. Like your network topology, you're either storing it in between sessions or you're rescanning it at the beginning of the session, and that can be a hurdle for a lot of developers. Both options can be. And then there's the wireless. I think we lost Minecraft.
The server is wireless now. Confirm exception.
Nice. Calling out correlated potentialistics and applied energistics too, because while they are really good for servers, they also demonstrate another one of the drawbacks, which is you wind up with a lot of, let's say, network cards.
You cut out Falcon.
What's that?
Sorry, you cut out.
I think he's the one who cut out.
Stop talking.
Okay.
Oh.
Cut out.
Last thing I heard was something about network cards. Still here?
Yeah, I'm still here.
I don't think he cut out. He was just pausing.
Yeah, we're kind of putting out fires, but you wind up with like device ID cards, network cards, and item filters and that sort of thing, and they're right now not shared very well between mods. I think that's something that we can really fix. I'm going to try and get back onto the server now. Yay, it's a real panel! We crashed during it.
Ooh.
So anyway, if any of those reasons or drawbacks sound not so compelling, it's because they aren't. Smart multi-blocks are definitely one of the main solutions that we have in our kit. And I think there's a lot of territory that we haven't explored yet in that vein. So I'm pretty much all set here. I think we have enough time. No, we don't have too much time left for talking about message passing. So I think I want to turn it over to. Yeah, I didn't have that much for the screen. We could have done okay without the pictures even. I want to turn it over to Q&A if anybody wants.
All right, because we have 40 minutes to the next panel, and there's technically 10 minutes left in this time slot.
Yeah.
Okay, so questions. Wouldn't it be pretty bad for the server to rely on block updates, like blocks communicating between each other instead of some optimized big network like an IO uses?
Yeah, I think you're right. That's why I pointed to Ender.io. It's one of the fastest mods, one of the best for the servers. Having run around with oh man, what's that tile entity heat map tool that spawns the extra window out? I always forget
Opus.
its
Chicken
name.
chunks?
Yeah,
Chicken
Opus.
chunks does that.
Having run around with Opus on really complicated servers and been shocked. On the other hand, if the closer you reduce the scope of your searches, the more you can prevent searches from happening entirely, the closer you actually start to approximate that logical sort of synthetic network map.
For something like a heat map, wouldn't it be more appropriate to put something like sphere over? I think. What's the best way to describe this? Galactic Craft does this for air. Those air bubbles. Wouldn't it be easier to have something like that and check if it if a block intercepts with one of those spheres? Or something like heat distribution?
Oh, you're talking about like a heat diffusion simulation?
Yes.
I think the best way to do a heat diffusion, honestly, is at a much bigger scale. So, like, instead of moving it from block to block, yeah,
chunk.
either a chunk or a small group of chunks, and run a much slower and much larger scale diffusion simulation that way.
Yeah, well, have fun chunk loading that.
Oh no, I would skip unloaded chunks. I would be ruthless in terms of allowing heat to flow along corridors where people travel.
So you talked a lot about the idea of cellular automation not being kind of feasible, scalably wise. Like, yeah, I guess you can't really process every chunk in the game. Is that what you're suggesting there?
Yeah, and so I'm saying it's probably best to give up that idea entirely. It's tough.
I actually posted something on Reddit almost a year, 10 months ago. A long ass link, but here's the link. And I talked about the idea of scaling out, like, to multiple servers and having message passing and dealing with being a proper finite state machine that is a cellular automation. And it might be interesting to look at. I don't know, because it was just I always wanted some good feedback from it, and it generated a little bit. But if you might find it interesting. I think the idea of scaling out computers, machines, making it so that the finite state simulation is extremely functional. It's not like an NP. Try not to solve NP hard problems in each cell. That way you can solve that cell's function easily, and then you could throw it in something like CUDA and run the whole simulation on a GPU or something.
I'm not saying it's impossible, because I want to say Skylanders, but there's a game out there that's written in Unity that actually does that. What you're talking about, it uses multiple servers kind of partition space out, and it can actually take the same space and divide it up differently each tick between the available resources, and
What game is that?
manages to arrive at some really reasonable collision solutions. So I'm not saying that's impossible, but there are some really smart, dedicated people that are building the whole game around that. So I'm a little bit more skeptical about having something like that in Minecraft.
Yeah, for Minecraft itself, about to adapt it to that model. So, being said, I think I heard a couple other people mention they're interested in doing something other than Minecraft. No.
Yeah, I might be one of those people that are doing something other than Minecraft. I'm actually
people are interested in building better than Minecraft. Oh, wait, what?
Yeah, actually, MMORPGs are a great example of exactly how you kind of best case scenario for load balancing, because they had to be. Yeah, maybe in one of the downtimes we can talk about a more discrete message passing automation, because I could probably go on for another half hour. Any other questions?
I had another question on, I guess, more like those blocks building network. Because that's kind of a hard problem to solve. Like you've got to solve if the network gets broken, how do you repartition it, that kind of stuff. Are there libraries available for mod authors to that stuff, or is there sort of generic interface to kind of help make those work better?
Yeah, I was gonna say we just recently got a library.
Thanks.
Yeah, this library was created at my poking in the Minecraft Forge IRC, and it's specifically designed for cable networks. If you're having trouble implementing efficient cables because you don't understand how graphs work, I recommend using this library. It'll make your mod fast a lot. Like it'll make it a lot fast, very fastly.
Much fast, very good.
Much well.
Better than 27,000 entities at the end that don't die.
Yeah.
Similarity. When did this contraption end up here?
I don't know, but that's a really attractive contraption there.
What is this?
People were building
What mod?
it whilst Falcon was speaking.
Everybody was just enthralled by Valkyrie's speech and just didn't notice.
Yeah, so
Every
Fox, I
time
have
I
a question
click
for you.
one of
Does
these
this Does
Everything
this style
lags.
of system, like the one in inductive automation, meet sort of the goals you described? Remember everything I've seen of this, it seems to be a lot of blocks that do one thing that interact with each other.
Yeah, it looks to me, just on casual inspection, like each block does one thing, and that it's really the arrangement of blocks that defines the behavior of your system. That's kind of the ideal cellular multi-block.
But it has solar panels. Unforgivable. I hate this mod. I'm gone.
Whenever
Well,
I
we've-
on one of these coils over here, it just like lags out my machine like crazy.
Colt, we were using solar panels like last map.
Yes, and that map was meant as a test to see if not disabling all the stuff would
You
make
were
the
the
map
one
last
who
like 10
kept-
minutes.
All right.
Why do
And
our
it lasted about 10 minutes.
panels?
Okay, guys, we can maybe take one more question, and then that's a wrap.
Did you give us a wrap?
Falk, start.
We're
rapping.
technically a minute behind schedule.
Oh,
I don't know. I mean, if I had questions, I could ask you whenever, so I'm not going to bother. Let other people. What is... What? No, whatever.
All right, well, I think then that's a wrap. Thanks, everybody, for coming and listening to me ramble. Hope it's been
thank
as
you
fun
for
as
rambling.
it was for me.
Enjoyed it.